Welcome to the SAGE's Climate Science podcast. I'm your host, Laura Young, environmental scientist and science communicator. And this is our first ever episode. And to kick us off, we are thinking big about what is climate change and how is it impacting Scotland. And to begin, I'm joined by Professor Matteo Spagnolo, the director of SAGE's, who is based at the School of Geosciences in the University of Aberdeen. Welcome to the podcast.
Thank you, Laura.
And you've done lots of work, almost too much to mention, but you have been a vibrant member of the Aberdeen Cryosphere and Climate Change Group, and you've held various roles at the University of Aberdeen, including the School Postgraduate Research Director, elected Senator and the Head of Geography and Environment. And you are a proud member of SAGE's since you moved to Scotland, and of course you took on this role to be SAGE's Director. And I'm wondering, to just begin setting the context, who are we as SAGE's?
So SAGES is the Scottish Alliance for Geosciences, Society and the Environment. And it's basically an idea that was born about 20 years ago when a number of academics from different universities in Scotland realized that there would have been strength in joining forces. And so they got together and put in a proposal for the Scottish government at the time. It got quite a considerable funding. And since then, so for the past 20 years, Scottish SAGES has represented around 10, now 11 institutions, in fact. Most of them are universities in Scotland, but we also have the British Geological Survey. And SAGES group together these institutions and the people in these institutions that work around the theme of geosciences in its widest possible term, so including environment and society, as the name says. And SAGES very much try to foster collaboration between institutions and between people who work on these themes. So climate obviously is at the core, at the center of most of our activities. So SAGES is grouping together academics, but especially is giving opportunities to young generation scientists to work together, to collaborate across different institutions. So SAGES at the moment has about 700 members, and almost half of these are PhD students or what we call postdocs, so early career researchers.
And throughout this podcast, we are going to have a fantastic number of different scientists throughout the SAGES network from lots of different institutions. And we're going to be talking about climate change in that broad sense. We're covering everything from snow and ice to soil to flooding to society, people, communities, and so much more. But for this introductory episode, actually, it's probably helpful to bring everybody up to speed on the basics of climate change. And so I would love to set you off on giving us the sort of basics on actually how has our climate changed over time?
Absolutely. It's a fascinating question or fascinating answer, I should say. But perhaps first of all, I should mention what climate is, right? Because people often get confused between climate and weather. So what we see around us on a day-to-day basis or perhaps seasonal basis is the weather. And that's what we talk about. Is the weather changing today? Is it going to rain tomorrow? Is it warming up a little bit the next day? And so on. So that's the weather. Climate is very much a longer term perspective on weather. So if you take the weather of many days, many months, in fact, many years, and look at the general trend of the weather over the longer time series, that's what we call climate. So climate is a way to remove all the noise that is in the weather system and focus on the longer trend. So is climate changing towards, for example, warming as it is at the moment or cooling as it was in the past?
And I think that's helpful because you can have a summer that is generally more warm, but you of course have days where it's soaking wet and raining, particularly here in Scotland. But of course we do see these trends. And so thinking away from weather, so not what was the weather today or what have we had this year, thinking about climate, how has that changed over time?
So climate has changed quite a lot. And I think the answer to this is very much in the time scale of the change. So we need to think in terms of the time that has passed since the beginning of our planet. So it's a bit mind-blowing because we need to go back 4.5 billion years ago.
Okay, that's a long way.
Yes, very long way, when Earth started, if we like. And it's almost impossible for humans to understand that length of time. So, it's easy to talk about it, but if we actually try to understand how much time has passed since then, it's almost impossible for us. If we think about humans who have been around for about 2 million years, that is just a blink of an eye of the entire length of the existence of the planet Earth. So over this very long time period, we do know that climate has changed, and I will mention later how we know that. But for the moment being, I should say that, of course, the farthest back in time we go, the more difficult it is to really know the details of how climate has changed. But we do have evidence that climate did change. So if we think about hundreds of millions of years, so
huge amount of time.
Huge amount of time. So in the hundreds of millions of years, what we see for the past at least, say, 600 million years is that there were phases where the Earth entered periods of what we called a greenhouse Earth, and then phases when it went into an ice house.
And that would be because a greenhouse is warm, hot, and the opposite is cold.
Yeah. And so what we know is that during those times, for example, during the ice house period, which lasted, millions of years, not most necessarily, but a large portion of the Earth was covered by ice sheets. And during the greenhouse periods, it was the opposite. So most of the land was ice-free. So that's what we know for those hundreds of millions of years. If we then move into the tens of millions of years, so in the recent past, let's say we look at the last 100 million years, about 100 million years ago, that's a time when we were in a greenhouse state. And most of the Earth was ice-free. We had tropical vegetation in many places that you wouldn't think of, including Antarctica, for example. We had dinosaurs and many other animals that really thrived in warm climate conditions. Over the past 1 million years, we then enter a phase where we had a number of glaciations, which were at a regular interval, more or less, throughout this period. So we had periods of glaciations and what we call interglacial, which were periods where the Earth was warmer. So during the glaciations, we had large ice sheets building up, including one that occupied, for example, North America, one that occupied most of Europe, and so on. So this is kind of the most recent climate change that we see. And if we focus on the very last 20, 30,000 years, around that time we had what we call the last glacial maximum. So it's a time when it was relatively cold and a lot of ice was present on Earth. And since then, the Earth has been warming towards the present. So that's roughly, what we know about climate changing over the history of Earth.
And would we class that change as something that is natural in the sense that it moved with these fluctuations and it happened basically on its own through changes it was having? Absolutely.
So this is definitely a natural climate change. And we'll see later how that differed from the present day.
Thinking about these changes that we've seen over the hundreds of millions, hundreds of thousands of years, you've said they've come in cycles, that they've happened sort of naturally, but what has caused the changes when we've gone into warmer or cooler timescales?
I think we need to understand, first of all, that climate has a number of factors that affect it. And we call this the forcing of climate. And some of these are external, some of these are internal to the system. But let's focus first of all on the external factors. I would say the key element about climate is the sun, right? That's where all the heat on this planet, or most of the heat on this planet anyway, comes from. So the sun has not been providing the same amount of heat to our planet over the billions of years of its history. In fact, at the beginning, the heat was considerably less, a good, remember correctly, 10, 20% less than present day. So this is one of the factors that influenced the climate very long term. Another factor that was really important, that has been really important, is tectonics. Tectonics is the movement of the continents. And essentially, this movement affected the amount of, for example, volcanism that occur on our planet. And volcanoes release CO2 in the atmosphere, which is one of the greenhouse gases which affect climate. And tectonics means that mountains are built when two plates collide. And so, for example, we have, say, the Alps forming, and the Alps, as they grow in elevation, are then eroded, and the rocks undergo a process that we call weathering, which, is not just pure erosion, but it's a chemical process that ultimately capture CO2 in sediments that are buried in the oceans, in the seas. And this has an effect opposite to the release of CO2 of the volcano. So in the sense, it cools down the Earth. So tectonics is an important factor when it comes to climate. And then the way the Earth rotates around itself and then around the sun changes over time. It's not perfectly, still it's not always the same. And these changes, we call them orbital forcing. These changes affect, again, the amount of heat that we receive from the sun. So these are the largest elements that affect climate over very long time scales. Then, of course, once the heat arrives on Earth, the heat is redistributed, and it is redistributed through ocean currents, and it is redistributed through atmospheric currents. And so this redistribution are affected by many different factors. So, for example, if a new ocean opens, again, we're talking about the millions of years, right? So it's not something that's going to happen tomorrow in a few centuries. But in the million of years, if an ocean opens up and it changed the course of the currents that existed in that part of the world, or change the atmosphere if a new mountain is built, and affect the movement, the free movement of air, and so on. All those elements would affect climate as well. Another super important aspect is albedo, which sounds like a bit of a strange name, but albedo is nothing else but the amount of energy that is reflected back from the Earth's surface into the atmosphere. And if you have a white surface like a glacier, a snow-covered landscape, most of the energy that comes from the sun, or a large portion of the energy that comes from the sun, would just simply be reflected, and the Earth will not warm up. But if that changes, for example, there is warming and the snow disappear and the ice retreat, the glacier retreat and the ice disappear, then the opposite happens, and this means that the Earth will warm up even more. So these are all some of the many dynamic elements that affect the climate, and which have affected the climate over the past many million years. So scientists have been able to look back at the climate of our planet and interpret why things changed again, over those time scales. And whether it was the building of a mountain that dominated, whether it was another source. But in almost all instances, they ended up realizing that CO2 played a key role. So none of the other factor alone was sufficient to explain, to justify why climate changed that much. So the role
CO2
of CO2 is
carbon dioxide?
Yes, absolutely.
Perfect.
So CO2, carbon dioxide, seems to be extremely important in regulating climate over many different timescales.
Thinking about today, when we talk about climate change, a lot of these processes you've mentioned are things that happen over very long timescales, but we are seeing change today, and change that seems to be happening every year. We seem to have different statistics coming out about that change. What evidence are we seeing that climate is changing, and what's causing that today?
So if we focus about today, we're very lucky because we have measurements and we can actually measure how climate has changed over the past, few decades, up to centuries ago. So we have direct measurements of climate. But since I mentioned the climate change also in the past, and thousands and millions of years ago, I have to explain how we know that a little bit. So if we go back beyond the historical recording of weather condition, which we then use to understand the longer trend climate, we have to use what we call proxies for climate, which are ways of essentially get climatic information without directly measuring climate. And what are these? For example, if I want to understand the climate of, say, 50, 100, maybe 300 years ago, I could use tree rings. So I could look at how the rings of a tree have been growing over this period of time. And that growth reflect the climatic condition of that specific place.
And for people who might not know that, it's because when you cut a tree, inside you have those different rings, and it grows a ring every year or every few years.
Usually,
and you can actually see how old a tree is by chopping it in half and seeing that slice in the middle.
Yeah, it's both how old it is, but also the thickness of those rings are telling us essentially how easy it was for the plant to grow that much that year.
So a bigger wedge would be better growth?
For example, yes.
Great.
That's roughly what the tree ring science is telling us about. So those are like hundreds of years ago. If we want to go farther back, again, there are many different proxies, but for example, I could use an ice core. So I can go on a glacier, I can go on an ice sheet, for example, in Antarctica or in Greenland, core the ice, and the ice accumulates over many years. And there are bubbles of air that are trapped in the ice. So I can actually analyze those bubbles of airs. I could reconstruct how old they are. And looking at the CO2 of those bubble of airs, I can actually get a measurement of the atmospheric condition during the deposition of that ice, many, potentially thousands or tens or hundreds of thousands of years ago.
So it's a little snapshot frozen in time, literally.
Absolutely.
Where you can analyse. Fantastic.
Yeah, it's super fascinating. If I want to go farther back, then I start entering the world of fossils. So I can look, for example, at sediments in the oceans and look at fossils and there are extremely complicated chemical way of analyzing the shells of microfossils that have been deposited in these sediments offshore that have been, constantly deposited there in the oceans for millions of years. And so I can get a sense of how things happen then. And beyond that, if I want to go, into the hundreds of millions of years or beyond, well, all I have really is some fossils here and there, which might tell me that there was this kind of vegetation, for example, or this kind of life in general. Perhaps some evidence of ice on Earth. So that's pretty much all I could get. But yes, there are so many different proxies, and altogether they give us a picture of how climate has changed over the many millions of years. But when we focus on present day we have direct measurements. And there are many different ways of doing the measurements, from the wind thermometers that we have outside our houses to tell us how cold it's going to be that morning as we leave home, to something much more sophisticated, which are balloons or using satellite and so on. But those are all direct measurements.
And so thinking about Scotland, where does that fit into this conversation?
So, if we wonder, is there evidence of climate changing in Scotland over a long time period? Probably the easiest way to answer that, but I'm a little biased because I study the landscape, will be to look at our landscape indeed. And so if we look around us, for example, we're recording today here in Glasgow, and Glasgow is largely built on a drumlin field. All the little hills that we see in Glasgow are actually drumlins, and those are essentially features that were deposited during a time when Glasgow and the entire of Scotland actually was covered by a very thick ice sheet, probably a good 1 or 2 kilometer thick ice sheet. If we take a walk in our beautiful mountains, if we go on the hills of Scotland and we look at the shape of our valley, we see a U-shaped valley, or we go to the head of those valleys and we recognize corries, which are kind of bowl-shaped valley head, and often with a little lake sitting on them. And all those are features that were carved by glaciers, which obviously are not here anymore. So those are telling us that in our recent past, so we're talking about maybe 20,000 years ago, it was definitely cooler than it is today, and there were glaciers all around us.
How do we talk about that? How do we measure that?
Yeah, so we really, when we talk about climate change present day, we typically use a reference period, which is the pre-industrial temperature. So we're talking about the temperature of, say, 100, 150 years ago. So we take that as our reference and we look at how the temperature has changed since then. So how many degrees the temperature has increased since that time. So you probably have heard that we are essentially hitting the 1.5 degrees Celsius. That is 1.5 degrees Celsius above
that time
standard temperature that we set is the pre-industrial temperature.
And I guess that links really nicely back to what you said, because the Industrial Revolution was the time that particularly places like the UK and other nations started to ramp up the use of fossil fuels, coal, now obviously more oil and gas. And those are what emit greenhouse gases, which is how we put that into the atmosphere, enhance that warming, enhance that global warming. Is that a correct analysis of why we sort of use that as a timescale?
Yes, absolutely. Yeah, that's correct.
Throughout our conversation, we've talked about some of the more natural ways, I guess, of calling it that the climate has changed, and that's changed over long periods of time. But you've now touched on the fact that actually we are seeing warming now that is very rapid, it's very quick, it's happening at scales that we've not seen before. And we take this marker from the Industrial Revolution, where fossil fuels came into play, which is changing our atmosphere because of what people, anthropogenic sources, are putting out there. So I guess people ask, is climate change natural? And you've both mentioned that it is and it isn't. So how would you answer, is climate change natural?
So you remember when I mentioned that there are different factors forcing that affect climate. We know most of them, if not all of them, although climate is complex. But certainly what we have seen pretty much since the Industrial Revolution onward, perhaps even earlier, to be fair, is that there's been a new factors affecting the system, affecting the climate, and that is humans. There's no question there. We do know that humans are releasing a huge amount of CO2 in many different ways into the atmosphere. And it's not just CO2, there's also methane and other gases. Those are greenhouse gases. Those affect essentially the amount of warming of our planet, because some of the energy that would naturally be released from the Earth back into space is trapped around the Earth into its atmosphere, and so it's warming. And what we know is that the warming that we're seeing today is very unusual. And it's very unusual because it's occurring pretty much everywhere on our planet, at different rates, but everywhere. In the past, we have evidence, if we focus on the past 2,000 years, where we really know a lot about our climate. So we have evidence of other times when things changed, but they didn't change everywhere. It's warming at a very high rate. So the rate of warming is unprecedented, really. And we're now reaching temperature that essentially were seen only 2,000 years ago. And if predictions are correct, probably within less than 100 years, we're looking at temperature that had not been reached for the 1 or 2 million years ago. So it's really dramatic, in a sense, what we see around us. But I will say that the most crucial element here is the rate of change. And if we look at changes of climate in the past, we see that in a way or another, the Earth has always been able to cope with those changes. But those were over those very long time, right? And clearly, there will be mechanism to, if we like, counteract what's happening today. But it might take a very long time. So it might take thousands of years before we get there, before Earth is restored to its natural or non-human affected climate. And that's too long for us. So we need to take action.
Well, thank you so much, Matteo, for taking us on that arc of really the history of the planet and thinking about how climate has changed over time, why that has been, why it's changing now, and some of those factors. And that is something that we are going to explore throughout this podcast, is actually how are we seeing climate changing? What are some of the different impacts, aspects? What are researchers doing to help us both mitigate and adapt? So that was so helpful for kicking us off. So thank you very much for coming on the Sages podcast.
Thank you, Laura.